that a person would get a different mass ratio.
No.
So I'm hearing a conflicting thing here. That's all.
It's a mass ratio.
Force to mass ratio.
Why don't you pick on something that actually has to do with blood pressure? If you were to jump out of an airplane and you're weightless as you accelerate, would your blood pressure go up or down?
Say that again.
0.
You jump out of an air. Let's say you jump off of a building or down a mine shaft that's a vacuum tube, and you jump out and you accelerate 9.8 meters per second squared. You're basically weightless as you plummet down this mine shaft. Would your blood pressure go up or down?
I don't know. I mean,
Probably go up.
probably from adrenaline it would go up, but
All right. How about this one? Is your blood pressure higher if you're at the bottom of a pool?
Yeah.
Is your blood pressure higher if you were in space?
Can't go there.
So you're at 100,000 feet or 30. Let's say at the top of Mount Everest, with probably 80-70% of the atmosphere pressure.
Yeah, there would be less pressure.
you have less. Yeah, you would probably have less, I would think.
Yeah, because your body's going to expand a little bit, and those
I bet your blood pressure is weaker underwater. Lower blood pressure underwater.
Yeah.
Why
Really?
would you have
Wait, where
lower
are you getting
blood
that?
pressure underwater?
Don't you compress things when it's underwater? Wouldn't all your skin be?
Yeah, therefore your shit pumps weaker, motherfucker.
What?
Yeah, because
The
What
arteries
are you
would be
on?
tighter.
Heart's always pumping. The seal in the heart's the given. The pressure is determined. Why do you think people get high blood pressure? Because they have arterial sclerosis, or they have hardened arteries, they have cholesterol buildup in the veins and arteries. That makes the passages smaller. That makes the pressure go up. Basically,
no, weaker heart.
I mean, no.
Blood
That's of course
pressure
why you
without
get.
a heart.
So, okay, the answer is underwater. You'll have higher.
Like
blood
if you're under more
Blood pressure
pressure.
isn't your fucking atmospheric blood pressure. It's how
Go
much
take
the
your
heart
bl-
is
Go
pumping.
take your blood pressure at the bottom of the pool and come back to us. All right.
I would think that it would be more just because of the pressure.
Your
Just because
heartbeat
your-
is gonna beat less underwater.
There would be less volume in your veins
Right.
if you be compressed, so it would be higher because your blood is still, the heart is still pumping with the same force.
Right.
Think about it this way.
Would it
If
not?
your
Would it
blood
not press?
pressure,
Would it not? Would your body not try to counteract the pressure by pumping more?
yes.
What?
You
Think,
raise the
think
pressure
about
more.
think about it this way. If your blood pressure didn't go up, then your blood vessels would all start constricting, and you wouldn't have enough blood anywhere in your body, and you'd die.
Well, if your blood vessels were constricted, that would basically be the definition of higher blood pressure, right?
There you go. So you've answered your own question. So it's not how much you weigh or how much gravity's acting on you that determines the size of those.
Force
passages.
that's acting on. It's a
It
force
has to
that's
be the
acting
air
on your
pressure.
body.
So air pressure is what we're talking about. If you put you in a vacuum before you died, what do you think your pressure would look like? That's not what you died.
So
by
it's
the way.
so it matters the force that's being imposed on your body that would make your heart pump faster or slower, right?
Well, yeah, but I suppose there'd be some conditions where you're accelerating, like you're in a centrifuge or something, where you could change your blood pressure. I mean, it's not a dumb question, but
right. That's what I'm trying to equate to.
It's a little silly because the amount of change, your overall weight is changing by about a pound, and I don't think your body's going to change its blood pressure for about a pound.
Well, it would adapt for sure, or try to. I would think.
Tell me how you calibrate this fucking experiment of weight differential.
Well, apparently there's weight differential when you move 500 milligram mass to one latitude to the other towards the equator.
How would you ever fucking know?
You weigh it with a scale.
Yeah,
Right, so
okay, that described, yeah, okay.
Right, so what would be the difference in that amount of weight measurement and the pressure that it's forcing down towards the equator? That's what I'm trying to see if that there is I'm trying to equate blood pressure to weight. that there's more or less weight, the higher or lower you go from the equator. So
What's the force that's being exerted towards the equator?
centrifugal.
How?
Is it making something weigh less or more at the equator?
I think more. I
Why
don't
would it
know. I
weigh
think it's
more?
bullshit anyway, but
Why? No, it's not. But you've already explained to how a centrifugal force works, and we've given you the equation for it, so you know.
yeah.
That,
I'll give you an equation for whatever you want. I can give
well,
you an
no,
equation
we've
for
totally explained.
a
Doesn't matter what
unicorn
the
force
equation-
equals rainbows.
We've told you that as you spin, you would get. You said this. Things would get pushed outward, and that outward push
Right.
would make you weigh less because every molecule in your body is getting flung outward. So if you were standing on a scale, you weigh less. So it's less force acting on the body.
So you agree with me that somebody's blood pressure would be different.
The less force in your body doesn't mean your pressure is going to change. The air pressure would have to be less, and that isn't changing.
What about the centrifugal force of the rotation?
What about it?
Well, let's say you're saying the air pressure. Let's say you're at the same sea level.
Oh,
Let's
okay.
just say.
So theoretically, should it be
Yeah.
0.2% difference? I guess I suppose it could, but that's such a small change. I don't think you could detect it. But yeah, theoretically, that.
Boom. Thank you. Thank you for saying that because that was one of my
There's a
that was one of
caveat.
my rebuttals.
There's a
to-
caveat. Hold on. There's a caveat to it. Sure,
Okay.
it's being pushed out, but there's more of it at the equator, so that might be equalizing that pressure at the surface.
Might be.
Well, I mean, we can go through a kind of a thought experiment on it and
Yeah.
put some things on paper.
Well-
But if you think about it, the reason you have air pressure is because of the hydrostatic forces. And the hydrostatic forces has directly to do with how much air is above you. And if there's more air above you, then you'd have more pressure. So and the reason you have more pressure or more air because of the centrifugal force. So it probably would counteract each other. Just
Well, can we?
I haven't tested
Yeah,
it
can
out
we
yet.
say everybody's at sea level from one latitude to the equator? And that was my point from what you were just saying, like a very insignificant thing. It's going to be hard to measure. And that was my point in my rebuttal to rocket scientists was that's what I hear a lot is one of three things. Either that's exactly what we'd expect to see, number one. Number two, too small to measure, or three, too big to see. So that fits exactly what I was trying to say in the
What's
text
too big-
chat
What's
to
too big to
rocket
see?
scientists.
What's too big to see?
Earth curve.
Oh, okay. I get it. Yeah, those are
Yeah.
all valid points because we have something called, human perception, and human perception has limits. We can only see and get a resolution of things that end up at the diffractive limit. We only can feel motion of a certain type of force. We can only see, we can only feel certain temperature changes. There's all these, we can only see things, colors and patterns and things to a certain degree as well. All these things have to do with human perception. So if it's beyond human perception, you ain't gonna feel it. You can't see Earth curve because it's beyond human perception.
Then,
Right.
Zanuck, then that picture that we see of Lake Pontchartrain, that's not Earth curvature. Correct.
No, see the naked eye versus a naked curve. Now, one thing nice about
Naked
Pontchartrain is that suddenly we're aiding the eye and the brain's ability to detect the curvature by having reference points along the way, reference points with respect to position. And so those reference points with respect to position in our field of view will allow us to see the curvature of the Earth. We're really seeing the curvature of these items, which are
Following the curve of the Earth.
magnifying the curve that we would see normally on just the curve of the water.
Okay, well then, what about this one then?
Hey, real
Is
quick,
that-
real quick. I'm sorry to interrupt. So, rocket scientists, are we good? I don't want to leave it hanging. I want to bury the hatchet on that. Do you see my point of view? I see your point of view. I get it. I get what you're saying. Okay. Fair enough.
You could
No answer, whatever.
could-
It's fine.
you
Okay,
could
sorry to
try to-
interrupt. Go ahead.
You could try to measure your blood pressure in an elevator going up and down, or accelerating up and down.
Okay, well, I don't wanna distract from the Pontchartrain thing that they were starting to go to.
Sure, I was just saying.
Yeah, no,
Jerry,
I
I
got
don't think that's a real picture. That second one, I can't find it referenced anywhere. So if you got the original source, that would be awesome.
Get it for you.
That looks like a graphic to me. That doesn't look like a picture, but I could be wrong.
Dross, you don't really think that's the curve of the Earth, though, in that Pontchartrain? I mean, is that you think
Oh
that's?
yeah, definitely.
Oh,
No
definitely.
fucking way.
Oh
No
yeah.
fucking
Oh
way.
yeah.
Yeah,
Oh, that's
I-
yeah.
I-
Okay. Oh yeah.
I-
Oh yeah. Oh yeah. Yeah.
You're asking
We
Well,
gotta
here
have
it comes.
We gotta
Here it
have at least
comes.
one picture of curvature somewhere. We gotta have it. Okay. Okay. We got it.
No, I mean, I'm just basically saying. To me, yes, that's what I believe. You asked me what I believed, and I told you.
All right, I just posted the video that it's from.
Thank you. Really appreciate it. It just looked really strange.
So why doesn't it look like that everywhere on Earth? Why can't we just look out everywhere and just see a big bulge, an absurd bulge of Earth curve?
I used to see it every single day when I used to look at wind turbines. When I lived up on the East Coast, and the weird thing is, if I go up on the big cliffs, which takes me up about 100 feet, 110 feet, I can see more of it. I can start to see the yellow bits at the bottom. When I'm at the shoreline, I can't. So something is hiding it. It's not always refraction.
It's a cartoon picture.
It definitely ain't an Earth curve.
Are you listening to Ron?
I think to say it definitely ain't Earth curve is, again, if that's what you believe, fine. If you're stating that as a fact, I disagree with you.
What is it if it's not Earth curving or the surface curving and those pylons curving along the
Yeah,
surface?
They can falsify it. They don't have to replace it. I kind of agree with that.
Clearly to me, it's clearly an optical perspective. It's an
Well,
what do you mean?
optical. Well, I mean, look at this angle. Look at the angle that you're looking at it. That's why it looks like that. If you were able to get a different view of it in one way or another, it would look different. I mean,
Okay, what if I'm above those pylons looking down at them? Would they bend up? And we would have the Earth curving up.
Hold on. You
You're
tell
looking at the
me.
day. That could be a
I
very
don't think it
heavily
curves one way
refracted.
or another.
That could be a very heavily refracted day. I mean, just saying that looks like, and we've seen this before in other types of examples, like the black swan and things. This is what you would see on a
Pictures
refracted
don't.
day. You'd see things that look flat. The horizon would be, loomed up.
Pictures
That's what
don't
it is.
prove anything.
It's a hazy day. Might be a
Yeah,
warm day.
that's-
Who knows what it is? It's just not enough.
That's always been my point, that pictures don't prove anything, and then people say, "Oh, but we have the black swan." It's like, yeah, sure.
Well, that's a whole different
It's a picture,
thing.
so
Yeah.
it doesn't prove anything.
Well, the QE, I call it the QE B period S period. Because it stands for black swan, but I call it BS. But that is a Modus Tollens logically formulated argument. The picture
Danny
is a
posted one.
separate thing.
No, the argument's
do you
horrible.
accept
It's
Danny's
a horrible
argument?
argument because all you need to do to debunk it, and we've done this a million times. I think everybody on the globe side has done this debunking. For somehow,
The picture is not a logical argument. It's in my opinion, it's used to distract from the logical argument. However, when I hear refraction,
look at my Modus Tollens. Look at my
I
Modus
see.
Tollens.
Oh, you have one?
Yes.
Oh shit, I gotta zoom in on it. Okay.
Okay, look. If P, then Q. Not Q, then therefore not P. So if the Earth is flat, then every object at your observation eye level will stay at that level in your field of view, meaning angularly from your field of view from level.
Yeah.
So if not Q, objects not at your eye level, the same height above surface and the distance, than not P. So the Earth is not flat because this shows that modus tollens not being satisfied.
Well, where does the picture come into play with that logical formulation?
Because we know, because QE and everybody else talked, oh, there's a 1 foot off the ground observer. Well, let's say it's 2 feet or even 3 feet. Look at the side of the guy's head. That guy that's about 2 or 3 feet for his torso.
Oh, is this
Yeah.
your Black Swan picture?
This is a picture that was taken by the same folks that made the Black Swan.
Oh, okay. I'm following you.
So we have the guy's head, and you're at 1 foot or 2 feet. Why is his head below the bottom of the oil wells if they're out in the distance and the Earth is round, flat, whatever? It's not flat. It has to be concave for that to happen. So
No, silly.
Yes, you can't have something that's at the same height as you.
What about the shoreline?
The observer. All that matters is the observers 1 or 2 feet off the ground. The surfer, we know, is a human being. We know his body and head have to be around 2 feet, and yet he is far below, in the line of sight, to the bottom of the oil rigs. So they are loomed up more than flat, or the Earth is concave. You pick. There's only two choices.
The lowest quality photo I think I've ever seen posted online.
Yeah, but the thing is, you're arguing from a picture, and I don't think that's
what he argues from. He's saying if you ever measure a horizon that's not 1.22 miles from the observer, 1 foot off the ground, then the Earth can't be flat. I'm summarizing what he says.
Eggshells.
And that's not
you
true.
were
all you need to do. All you need to do is have refraction, and therefore you will have looming, and therefore you'll have a flat-looking Earth. And all you have to do is prove it wrong. Wait, hold on. All you need to do to prove it wrong is start changing your observation point upward in 10-foot increment, and you can plot out the amount of deviation because you know how far these objects are away. And when you start factoring, hold on, let me finish. When you factor out what that change is in position based on trigonometry, you'll realize that you can actually plot and understand what the refraction is at the lowest point because you'll have a plot of it. So no, his modus tollens is completely wrong. It is very flawed and doesn't work.
Okay. So
I kind of agree with where you're going there. I think. Sorry, go ahead.
One thing what I will say is, number one, eggshells. I think you went through this with. Maybe you bounced out before you got into it with Bev about this. But I know Gummy Bear went through this with Bev at one point. But my point is, no matter which way you want to look at it, from whatever point of view in your mind that you want to look at it from, this entire argument in general, refraction does not change a measured distance. It changes
by measurement. What do you mean by a measured distance? So I can understand.
Well, yeah, sure. So a measured distance from when somebody says that oil rig is this far away from shore or whatever, right? Those measured distances are known, right? So refraction doesn't change.
Stop for 1 second. Hold on a second. I showed a picture.
Okay.
Your measured distance would be the same in two exact objects. One is half missing, and one is completely in
I don't
view.
care. That's not even what I'm talking. It's not even.
But you're saying that it's a measured distance. We know they're both.
Well, hang on.
9 miles away. So why is one?
Hang on. Let me finish. Let me finish my thought.
All right.
Yeah. So refraction doesn't change the actual measurement of distance. Refraction can change the perception of it, but it doesn't change the actual measurement. So if you're saying that oil rig and that oil rig is X from this point and Y from this point, whatever, that distance remains the same regardless of refraction.
Sugarcoat, one quick question. So if I do trigonometry, so if I have two observation points and with a known distance between those 2 points, and then I use trigonometry, I can work out the distance of those oil rigs, yeah? Do you agree with that?
If you have a known distance, then you
already
know.
I know that me and riding on eggshells are 1 mile apart.
Right.
And we then both take an angular measurement to that oil rig, and then use Pythagorean theorem to work out the distance to the sides of the triangle.
A
You good with
squared
that?
plus B equals C squared. Yeah, sure. I follow you. You can do
Cool.
whatever measurements or whatever
So
calculations
would
you
you
like.
agree that then becomes a known distance?
It's already a known distance before you did the
No.
calculation, right?
I don't know the distance to this particular object. No one's ever actually calculated this specific point. No one's rolled a tape measure out from it. We're using trig to determine a known distance, to make a known distance. Are you happy with that?
Well, yeah, but that's not entirely what we're talking about with this.
Oh, no, this is very important to what we're talking about.
Well, we're talking about known distances.
No, you're
Yes.
like the
And whether I'm not talking about pictures. I'm not talking about pictures and what you
No,
can
I'm
see.
talking about. Yeah,
Just listen
I'm
to
talking about taking an observation in reality and creating that measurement so we have a known
No,
distance.
we're not creating measure.
Listen,
no,
okay, let me foolish. Let me speak him. He's not speaking your language for some reason. Listen, you don't know how far something is, so you use the angles to figure out how far it is, and then see if it matches how far away it is, because you can pace it off or use a tape measure or something, right? Foolish. That's what you're trying to say.
Well, no, I'm just saying that to take that measurement out to the oil rigs, they've done it in some way, shape, or form. They haven't run a tape measure out to it to say, oh, from here it's 9.6 miles to that oil rig and 6.1 to the
all of
accommodation
a sudden,
center.
we're not relying on Google Earth now.
No, I'm just saying, if I've got somewhere where I don't want to use Google Earth, where I don't have access to the internet, we can create a known distance, and we can use trigonometry to do that. And I'm just trying to see if you agree with that point or not. I'm happy if you don't. I'm happy if you are.
Yeah, I mean, it sounds like you're trying to recreate the wheel on a known distance already. But what I think where you're going is not my point.
You don't
Yeah,
accept Google Earth.
all I'm trying to do is say, well, one, you're using Google Earth, which uses a spherical geometry to create its distances. So I found that a bit weird. All I'm trying to say is, if I don't have access to Google Earth, I don't have an accurate map of the area, and I need to create my known distance to do this observation. Can I use something as simple as trigonometry? Two observers 1 mile apart, and then take an angle.
I think you can do whatever you want.
I'm asking if that would be an acceptable method to you. I'm trying to get your opinion, and for some reason, you're absolutely avoiding any commitment to it one way or the other, and I don't know why.
Hey, foolish. Just chill. This isn't what
I'm
you're
very
having.
chilled.
You're having your points. I understand your points. You're using trigonometry to find distances with angles. I get it, but that is not
Is
what.
that an acceptable method to create a known distance to you?
Why would you do that to create a known distance? I think you keep using words that I have to disagree with for some reason. Why would you do that to do a known
that it
distance?
creates an accurate measurement then?
To a reasonable degree, probably yes.
Cool.
But that has nothing to do with what we're talking about. We're not guessing here on
That's not
this
a guess.
whole black
You just
swan.
said it's reasonably.
Okay. Can we get back to the point of the picture that Zanuck posted, please?
Yeah, I just wanted to know if trig was an acceptable method to create a known distance, and you kind of say, yeah, it's reasonably accurate. I'm good with that.
It doesn't make sense to do calculations on something that's already known. That's my point.
Well,
And
you
that's
don't
what
validate
keep
stuff. You don't
saying.
check stuff. You just blindly accept it.
I'll answer by saying
No, that's not what I'm saying.
depends on what it is.
That's not what I'm saying at all. However, back to what we were talking about and what the picture that Zanuck had with the argument that we were talking about.
Tunnels, yeah.
Yeah.
Well, here's the point. Let me clarify real quick. For example, what he's saying is what I was saying, and I don't think Philip was going this way, but he kind of was in a way. We measure the angle to these objects. Let's say the roof of the oil well that's 9.5 miles away, that's half missing, and we see if that 80-foot rooftop matches up with its angular position in our field of view. If it does, then we say, okay, good. It matches the distance because we know the distance at 9.4 miles away. And if we're 6 feet tall, that 80-foot roof should be at this angle above level, and we measure that. But then we take the black swan picture, and it's well higher, well above to where it should be for that distance. So why would you think that picture is correct, or
I
those
don't,
objects are where they should be when they don't map out trigonometrically at all? They're not even
I-
close.
yeah, my position on a picture.
Can you answer that question real quick?
Yeah.
One
My
shows
position.
the horizon. Maybe
Are you
at
going to
that-
ask me to answer a
I
question
know,
and
but
then
I'm
interrupt me
clear-
while I'm
but
answering a
clear-
question?
You didn't
Come on,
answer
Danik.
because you didn't answer it the first time. I'm just reiterating a little bit. The one picture shows just about all of that oil well, a little bit missing at the bottom, but let's say the horizon is right at the base
Okay,
of
so
it.
you're going to ask me a question and
Hold on,
continue
I'm
to
just
ask me a question
clarifying so you
again
have
while
all
you're
the
asking me to
information.
answer it?
I'm clarifying
This
so you
is
have all the
fucking bullshit, dude.
information.
Come on now.
The second one, the oil well is half missing. So what do you have to say to that?
My position on looking at a picture is a picture is going to show different shit at different times of the day. That is not my point. I agree. My point is with any of these pictures, it's just a picture and they will be different at different times. Refraction is a thing. I
Right.
understand that.
Okay, then why do you use it? Why do
But
you use the most
because
tone
here's my point.
for a loomed up
here's my-
oil well and say that's a fact? Or that
Here is my
that
point,
cannot
Zanuck.
be round?
What? Hey, now you're complaining. You always complain about being interrupted.
No, I
Now
was
let
asking
me
a quick
finish
question.
my point, please. My point about any of these pictures is that refraction does not affect a known distance.
But it's not known anymore. If you do the trigonometry, like I just mentioned to you, and you use that for a known distance, and it doesn't work out, then something's got to be
But
an
are
error.
you using? Let me ask you this: are you using trigonometry after looking at a picture to verify a distance because a picture doesn't match up? That's my whole point. Like the black swan part of it, like the black swan argument to me is not a picture.
It is. It's based on a picture. If you observe in a horizon
Based on a
hold
logical
on, let me finish.
formulation
I
of
let
a
you finish.
modus
I
tollens.
let you finish. I let you finish. He says, if you observe, let me finish. If you observe a horizon that is farther than 1.2 miles, then the Earth cannot be round because it has to be. If it has
Roughly,
the radius of
roughly
30,
what it is.
3,900 miles, then the horizon can be no more, and it's part of his most tollens argument, no more than 1.22 miles away from the observer. That is 1 foot off the ground. And I'm showing you that no, that's not the case.
Okay, fine. I don't care about that. What I look at personally is a logical formulation of the if P then Q.
But
Whether
what's the
or
logical
not there's a
formulation?
picture
Can
that
you
backs up
articulate
any
it?
of that shit is, up to you. But there are, on top of that,
What's the
what I
modus
will
tollens for
say
the
is that
argument, Sugarcoat? Can you
what
just
I
go
will
through
say,
it?
yeah, but what I will say is a picture that has refraction in it clearly. Refraction does not negate or change a known distance from one point to another.
Yeah, but what's your logic? Can you give me the logical formula that you're using so we understand your point if it's different from what QE's saying?
You want me to
Yeah,
give
spell out
you
your modus
QE's
tollens.
argument? No,
No, I
modus
want
tollens
your
is
logic.
P
No,
then
you.
Q.
I want. No, Sugar. I said yours, not QE's. If it's different from QE's, can you give me your logic, your argument, your modus tollens, whatever, however you want to formulate it? I'm not that fussy when it comes to that shit.
Well,
You don't need if P
I would
equals
have.
Q, blah blah blah. So what's the basic premise of it?
P.
If you see too far, the
No,
Earth can't be flat. What is it?
That's to me that is a problem with the entire argument because of the picture is you see too far. I think that's a bad argument in my view.
I agree with you.
Yeah, I think pictures are a very weak form of proof of anything.
Yeah, I agree
because
with
of
you
all of these
because,
things.
well, yeah,
But
you know,
how,
you can argue for manipulation, you can argue for condition, you can argue the settings
right?
of the
No,
equipment. There are all these objections that people come to. I agree.
right. Yeah. So
What? Yeah, go on.
minus is if we could take the picture out of it, like pretend there isn't even a black swan quote
Just give me a
picture.
logic. What are you
Yeah.
arguing for?
If P, then Q.
So
If
what
not
P?
Q, therefore not P. So
Cool. So what's P
I
and
don't know.
what's
Let me
Q?
look. Hang on, real quick. Let me look up what the black swan argument actually says.
I think Zarek knows it off the top of his
I
head.
told you what it said.
Yeah, but I want to get it like. I mean, if we're
I
going to
told
argue
you.
QE's argument,
No, I'm not. I
we're gonna
want your
discuss.
no.
Yeah, that's
Sugar,
what
sugar.
let me
Wait. I
rephrase. Let
don't
me
want to
rephrase.
argue QE's argument. You said it seems. You know, I have to. It's a logical thing for me. I want your argument, not QE's.
I don't have. Well, the modus tollens is not mine.
I'm
That's
not
just how a
asking
logical
for. I'm not
statement is
asking for
formulated.
modus tollens. I'm asking for this logic that you seem to that suggests something. It's cool if that's kind of not what you meant and I've misunderstood. I'll happily back off. Not trying to be a dick because it's quite early in the morning for me, and I know to rein myself in a little bit with my enthusiasm. But you mentioned there was for you it was logical, and there was this logical argument or this logical view that you had, and I wanted you to unpack that logic. But we've gone a fair way down the road since then.
It's a modus tollens is formulated as if something.
I know what a modus
And
tollens is. That's fine. I want your argument. What you
for
are
what?
arguing for.
I'm not arguing for anything. All I'm saying, my point of the QE initials BS is the fact that there is a picture that is getting conflated with a logical formulation.
Mm-hmm. Do you agree with his logical formulation?
I agree that the logic is formulated correctly.
Okay, I didn't ask if it was, correct in its formulation, because again, you still got to demonstrate the premises are true if you want to make it a deductive argument. And you'd have to show that they're sufficient
Are you?
if you're doing an inductive argument. That's fine. I understand all of that. That's not a problem. I do a bit of formal logic. What I'm trying to understand is, what do you agree with? You agree with the conclusion of the argument?
Well, I think that's what's in contention in my point of view.
Yeah, I'm asking your opinion.
Yeah. My opinion is that, hang on, let me actually look at, hang on, again.
No.
Has somebody posted it?
Let's put this on the back burner. If this is not something you're comfortable with at the moment, let's put it on the back burner. You go and look at stuff. We can always pick it up later. I'm going out of my way this morning not to be a dick.
Well, thank you so much.
That's all right. I know I can be a pain in the ass.
I mean, if it was me and I was going to try to debunk the QE BS, I would say I would go for negating the Q, or I would go for disproving the entire premise. And if
I just don't think it's sufficient.
if I was a glober, I would say that the P part of it is I would say, I believe it says, if the Earth is a sphere of a radius of X.
Yeah.
I would say, well, we all know the Earth isn't a sphere, it's a geoid. If I was a glober, so therefore the entire premise is fucked, therefore the conclusion is fucked.
I
That's
think
just me.
I think there are multiple areas that his argument is not sufficient.
I
That's
agree
a nice
with you.
way of saying it.
I agree. There are different ways to totally pick it apart. And
you can't use that kind of logic. You can't say if the observer is at 1.22 feet,
That's
one foot.
that's
Hold
the
on,
P part, though.
1 foot. Then the horizon can be no further than 1.22 miles if the Earth has a radius of 3,900. But yet we see this horizon further than 1.22. So therefore, the Earth is not round. That's flawed.
It's not
No,
sufficient.
Well, therefore, yeah, I agree that
flawed because
therefore,
we know
yeah,
refraction can loom objects up.
yeah, I agree.
It's
Okay.
not sufficient because it's an incomplete. Go on, Ed.
So how do you
It's
do
a
that
lousy
logically?
argument for that reason alone.
The logic, to me, the logical rebuttal to it, as a logical formulation to negate that logical formulation, is to say the conclusion is fucked because it doesn't disprove the number.
Well, no, it's just the fact it's an insufficient description to come to that conclusion. I would just attack the sufficiency of the argument. It's just not there.
Yeah, it's like saying if I can't see the end of the train therefore goes forever. It's just like it's formally logic. Well, it is.
The reason why I disagree with you.
Just say that's fine. Let me finish it though, which is if you are disproving a radius of a certain size, fine. There are still problems with that logic, but fine. That doesn't mean you've disproven that there is a radius. What people have to invoke in order to prove that there is no radius is to go, oh, well, then how could you do space travel if you didn't know the radius? They have to invoke something that's totally not there in the black swan argument. So there are a number of ways it's formulated improperly. Not counting into refraction is one of them. But one of the main ones is it goes, if it's not a sphere of a very particular size, then it is a totally different shape.
Well, I agree with you halfway.
That's good. I'll meet you halfway.
Yeah. So we are, can somebody, I can't find the damn actual thing.
Do you want to go and get the modus tollens for you? I've got it somewhere. I think
No. Yeah, hit the actual BS modus tollens, the black swan modus tollens. I agree that there are issues with it.
Do you understand what I mean when I use the word it's not sufficient?
Yes, I do understand what you mean by
a logical.
It's not
from
sufficient.
From a logician, from a logical perspective, when you're doing formal logic, but there are different rules for doing an inductive argument than there is for a deductive argument.
Yeah.
He's trying to make what I would assume to be an inductive argument. So therefore, we need to look at the sufficiency of the premises used to create that modus tollens.
I think that the logical argument is based on Earth curve math. That is a given.
I think there's another issue.
If we can have one point, I just want to end with. Well, if we can have a known distance, we can have a known curvature.
If the thing we seem to start on is, do you trust distances? And I think that what has sounded like been discussion since before.
No, Zanuck, that's not it.
Not Zanuck, that's riding on eggshells.
I'm riding on eggshells.
No. I'm sorry. Zanuck posted something. That's not the actual thing.
Yeah. Can we let riding finish?
Using modus tollens.
Can you let riding finish?
Thank you. I think that the arguments seem to be revolving around, can we know distances exactly, perfectly? No, but if we can use trilateration here, triangulation there, straight up measuring things with undersea cables here, we can use it, same as you might measure a bit of wood 5 different ways. You'll get closer and closer. And if it looks like the answers of this length of wood is 4 foot long, your answers are converging towards 4 foot long, and then one of them's way out, you're going to go, that one's wrong. So we do have answers that seem to be converging on the distances of capital cities from one another, right? Or, overseas and things like that. And all of those need to be vastly wrong. Now, every one of those in isolation could be showing that there are many problems with it. As what's his name was pointing out before, I'm forgetting his name at the moment. Where is he? The sailing guy that's obsessed with the sailing. two of them. It could be wrong. Yeah. How much water flows under your hull is not a 100% indication of how far you've gone. But if you compare that to 20 other things, and all of them seem to be saying this is how far it is from, New York to LA, you can start to develop confidence in that, couldn't you? Or is there something logically unsound about what I'm suggesting?
I mean,
I don't think you understood what you said.
If you keep repeating the same measurement, what you do is you start to create, your bell curve.
Yeah.
And that's your curve of confidence. That's kind of what I go. If you've only got multiple methods you're doing, that gives you even stronger confidence because now you're doing different methods that are coming to the same results. And you'd expect to increase your error bar, not decrease.
You'll know what this one's called. It's like I've been listening to fundamentalists, not fundamentalists, what are they called? Foundational or something like that. This idea of, Darth Dawkins goes on about this, where the idea is your knowledge is a singular tower built upon a base foundational brick of what do you know is true. And a competing idea of knowledge is that it's more, I forget the word for it, but it's more like a crossword, where the first time you think this word might be embarrassment, you go, oh, is it embarrassment? Does it start with an E? And you might have a low degree of confidence in it. But once you've got like 3 or 4 words that intersect with it, it gives you a higher and higher degree of confidence where your whole presumption doesn't rest on a single clue. It rests on these other clues.
It's an aggregation.
It sort of intersect with it in a meaningful way. So if you've got these measurements that are everything from like how long does it take a plane to go from here to there, down to where do people sail, to do coordinates, does latitude and longitude reliably point at a singular place on the planet, then you can start to develop a higher and higher degree of confidence.
Okay, eggshells. Okay.
I put the modus
I don't know what
ponens
that was
chat
all
for you.
about. Yeah, I see what you just posted there, Zanuck. That's what I was looking for. So I think this is what we're coming down to is talking about the actual if P then Q, that not Q, therefore not P. And this is the QEBS black swan argument. And it's logically formulated as this, and I'm reading it from the thing. If
There's
the
a problem with
Earth,
every step, so we're going to have to stop you a lot. But yeah, go for it. If the Earth,
well,
has a radius of 39.59.
let me just read the logical formulation, not the conclusion. Okay.
Sure.
All right. So if the Earth, this is not me, this is QE. Okay. If the Earth is a sphere with a radius of 3959 miles, that is the P.
That's also
Then,
relation.
Yeah, so I've got a problem there. But carry on.
Let him finish.
Yep.
Yeah, then horizon distance measurements must be no more than 1.225 times the square root of observer's height in feet, which is Q. And then there's a note that says C curve calculator. And I think that's where those measurements are coming from.
Right.
Based on
that doesn't mean that we can't measure
that.
something different than that. That's the problem here. It can be measured more and more because we don't have a situation where we're measuring a geometric horizon every time we measure it.
I think I like the QE says that the horizon is caused by the curvature of the Earth. So therefore, if you have a horizon, the Earth has to be curved.
So then it goes into the disproving of the Q, which is how you would negate the argument is not Q, which is horizon distance is greater than 9.4 miles, therefore not P.
Right now, is that logical to you?
Well, not Q, then therefore not P is definitely logical.
No, because you started out with a illogical statement.
It's like I started a statement saying every dog is brown. Therefore, if this is a dog, then it will be brown. I can still make a formally logical argument that is false if one of the premises is false.
Hold on.
If I see you
exactly. Hold on. Let me address. Can I address that?
No, real quick. If I see you, you exist. If I don't see you, you don't exist. So in a dark room where I don't see you, you don't exist. It follows the logic.
No. Okay, you're talking about two different things. You're talking about a modus tollens. Yeah. Can I explain? what you're describing when you say a statement like that is equivalent to saying, if the sky is blue, it is not raining. That statement is a modus ponens, not a modus tollens.
Regardless of what it's called.
No, it's not no, it is. No, they're two separate things.
3.95, it is not a globe.
Eggshells, yeah, they're two separate things.
So
You saying
whatever
he
they
formulated
are,
this as a deductive argument? That's bollocks. Oh, sorry. That's the difference between modus ponens and modus tollens. There's inductive and deductive.
Right. So the equivalent of what you were saying is a modus ponens. This is an argument of a modus tollens.
It's
And
flawed.
so to negate
regardless of
it,
what it's called, let's
to
just
prove
use
the-
the logic.
If P,
Let's
then
forget
Q.
about whether it's a
To
modus tollens,
prove the
modus
modus
ponens,
tollens,
or a modus
to-
tardens. Like, regardless of it, just explore the logic. It's like
let's do that.
Okay, good. So if the Earth is of a radius X, you will always get the horizon at Y.
That's not how logic is formed. No.
Right. Well done. That is the argument,
exactly
though.
what
That
he
is
says.
how the argument
No.
is formed. That is how the logic is formed in that argument.
That's what he
Is it
says.
not?
Exactly.
No,
He
it's
says
not.
that. Read
He
it.
said, if
No.
the horizon
No,
with an
No,
observer
you're
height
missing,
of blah.
you're missing some. You're
no,
definitely
you
missing
read it
some
yourself.
details
You
here.
said if the Earth is a sphere with a radius of
If you're
3959,
going to argue formal logic, then you need to understand the framework you're working under. This is what Sugar Cookie is trying to actually tell you. And this is the difference between a modus ponens and a modus tollens. The problem is that if he's shifting it to a deductive argument, which is what I think that Sugar Cookie's saying, then he has even bigger problems than if it was just an inductive argument.
No, here's the thing. Can we time out real quick?
Sure.
I agree with you guys that there are
It's
flaws in this.
Hmm.
However, in order to show it's flawed within the logical framework of this, you have to say how to negate the Q part of it. So the then horizon distance measurements must not be more than 1.226. So you have to show that part of it wrong. And then if not Q, then not P. Don't get it twisted. This is not my argument. I am not defending this argument. What I am defending is the logical formulation on it.
So
That's
it's
it.
a logical. It's a logical formulation in terms of the way he's put the P and the Q around from one another is fine, but it's the premises have to be right for the conclusion to be right. The premises are wrong. The premise.
Okay, so
that
the premise. Let's go
Please
through
let
that.
me finish. Please let me finish. The premise that the horizon must always be a set distance from you is not accepted. It is a faulty premise.
That's not the premise. That's not the premise, dude.
Read
That's
it
what
out
I'm trying
again.
to
Read
say.
it, please.
it
Please,
is the
I invite you
premise,
to read the
you
whole
read
thing
it
again.
yourself.
Read it out again. I will tell you.
If the Earth is a sphere with a radius of 3959 miles, that's the P formulation of it. Now, if you
Yes.
want to go and say,
no,
nope.
don't stop there. We're arguing about the very next sentence. So don't stop at that sentence.
Okay, well,
the very next sentence is the horizon must be no further than. Go on, read it.
so
The horizon must be no further than.
Are you going to interrupt me while I'm getting ready to read it?
Both P and Q premises, by the way, Sugar
So
Cookie.
this is the Q part. Is then the horizon distance measurement must be no more than the horizon distance measurement must be no more than 1.225 times the square root of observer's height in feet, which is the Q part. And then there's a note that says see curve calculators.
Yeah, we're not
So
unclear on
that is
but
where
there's a curve calculator that gives
so
you
the curve
incorrect information short of refraction.
So
are you changing what you just said? Because that's the fundamental bit I was just talking about, which is
that's what I said at the beginning. I'm not changing anything. I'm reading it all the way through again, for several times.
So let me clarify to you again where I see the problem with that, and the problem is quite simple. It is that fundamental formulation of if the Earth is of a radius x, then you must get the horizon at y is false. that is false, demonstrably false, it is often coupled with a photo of the horizon in a different place.
The photo
So-
doesn't have anything to do with this.
Oh,
That's the-
let him
that's the
finish,
conflation.
please. Please let him finish.
Yeah, the problem is you're talking about a photo. The horizon.
Right.
will be-
Yannick, please let him finish.
He did finish. Okay.
It's a simple comment. Yes, the horizon will be there. It's called the geometric horizon. It'll always be at 1.22, always. And if it's not there, then you're right. It wouldn't be a sphere. But we see it not to be there because now we're looking at it optically and we're looking through a medium that shows refraction characteristics,
Yes.
and that
Okay.
moves it. That causes looming or stooping.
Right.
Exactly. We know that.
I agree with all of those. I agree with all of those rebuttals.
Overheard.
So let's
You can't- you
simplify.
can't be
Let's
the-
simplify it for both sides. For
He
both
agrees.
sides,
What's the problem?
whether
I'm
you're
not
flat,
on a
whether
side.
you're flat or round, whether you're flat or round, to rely upon the horizon for a measurement of something, the horizon must stay still. Can we agree on that? And if the horizon moves,
No.
we cannot use it to make a form to use in this formal logical argument to determine the shape of the Earth. If it moves,
No.
it's a bad way to measure the Earth. Okay, okay. Where am I wrong on that?
I disagree with what you're saying only because
Which bit?
yeah, that's what I'm getting ready to say is
Go
only
for it,
because the measurements are coming from a curve calculator. So the modus tollens is based on given measurements. The photo has nothing to do with this actual formulation. That's my point.
So we can discard the photo. The modus tollens is what we're talking about, which is if the Earth is of given radius, then the horizon must be in a certain place. That's the challenge. Please let me finish.
Well,
That's
if
the
the
challenge.
Earth is a sphere
Okay, don't let me
of a
finish. You go
given
for it.
radius.
You speak. It's probably more interesting for you to argue with yourself.
Well, no, I'm not arguing with myself. I'm just, I
You're
thought we were
interrupting
having a
my point,
conversation.
and I hadn't really made it yet.
I thought we were having a conversation about it, but you skipped a couple of words in the P part of the formula. And that's kind of what I'm also kind of getting at is if the Earth is a sphere with a radius of
Sure.
X,
If
Y,
the Earth
Z.
is a sphere of a radius of x, the horizon must always be y distance from us is broken. That's all I'm saying.
Okay, well then,
If
then
it's not broken,
the logical,
then you need to answer the question: does the horizon move? With no. If the answer is does the horizon move? No, let me finish. If you answer the question, does the horizon move? With yes, then that P then Q argument breaks because you cannot get Q out of a moving P because it would be delta P, wouldn't it?
well,
It wouldn't actually be delta P.
there's
But
nothing.
the P value would change, so you cannot take
There's
Q to the
nothing.
bank.
All right, can I reply?
Please.
There's nothing in that statement. If you're going to disagree with that statement, then you have to disprove the curve calculations that are made within that statement. You can say refraction and all the other things, but when you're doing that, I think you're inadvertently bringing the photo into what your rebuttal is inadvertently. But I think if you're going to rebut the numbers that are given in the curve calculator, then that's what you would need to do. Or,
So
in my opinion,
let me make it simple so you know what exactly it is you're responding to. If your answer is, I will ask this question, or I'll finish with this question to you, and that is, does the horizon move? If your answer to that question when I finish with it is yes, does the horizon move on different days under different refractive conditions, then the P then Q argument is broken. If the horizon doesn't move, then you can take it to the bank. Does the horizon move?
yes.
Thank you.
However,
Okay. So how can we get a no further than measurement when the horizon moves?
the point is that's not part of the argument. The part of the argument that you need to rebut is the curve calculations that are within the logic.
No.
You see what I'm saying?
No, the part we need to rebut is the logical formulation of the argument. We can rebut any part of it, right? If you show any premise to be faulty or any conclusion to be faulty, you can rebut any of it.
Right.
You seem to be complaining
within
about
within the formulation.
All right, you go for it.
Within the formulation. Well, when you're bringing in refractive indexes and you've already seen a photo, to me, that means you're being misdirected
So I
from
didn't
the
mention a
actual
photo.
logical
I didn't mention.
statement.
I didn't mention a photo. I didn't mention.
I didn't
refraction.
either. I did.
I asked you a really simple question, which is,
I
does the horizon move?
answered it.
Okay, let me do it this way. Let me do it this way.
You can ask me the same question over and
no,
over.
I'm
but
going to put it in a different way. Let me finish it though. If I've got a car that's got a speedo and the speedo wavers back and forth, and generally speaking, it's not more than 5% higher, not more than 5% lower, then, but it's not accurate. And then a police officer pulled me over for speeding, and I said, "I swear, officer, I was doing 100." And he said, "You were doing 104." And I said, "But my speedometer clearly said I was doing 102." Would you think that would be logical? If I had some unreliable thing that said, if my speedo is showing 102, then the horizon must not be 102 further from me, would that be logical? Or if I was using a wavering, unreliable measurement, it would be silly to use that to come to a reliable conclusion from it. Remembering this conversation flowed on from, how do you know how far you are from things? Like if one thing's unreliable, if we go,
So what's the question? What's the question you want me to answer?
Okay. Would you think it would be reasonable if I had a speedo with a 5% variance to take to the bank a reading that was within that margin of error? So do you think it would make sense to argue with a police officer if my speedo said 102 and he said I was doing 105, but I knew my speedo had a 5% error margin? So I could have been doing 107, could have been doing 98, 197.
I don't know. What's the margin of error of the radar gun that he got you with? I don't know, dude.
Exactly.
That's not the fucking point. The point is, no.
What do you think my point is?
I honestly don't know.
Eggshell's point is that the horizon is apparent, therefore the argument is invalid.
Exactly.
No,
the horizon is apparent.
I don't care. I don't care.
So from your own construction, if you
it's
say
not
the
my
horizon,
construction.
No, not your construction. From what you've said, you said to me, I said, "Does the horizon move?" You said yes, unequivocally. Right? You still happy with that?
Of course it does.
If the horizon moves, how can I have a logical conclusion that will be no further than?
Well,
how can I say
I don't know.
The horizon will be no more than 1.22? So could the curve calculator be wrong?
Eggshells.
Sorry, I've been speaking a lot.
Okay. So the only thing that has to do with this logical formulation, if you have an argument against it, then you have to prove the curve calculator incorrect that is being used in that formulation.
No,
if the curve calculations are incorrect, then take it up with the curve calculations that are being used for this formulation of logic. Not me,
no, I don't.
Not the photo, nothing else. Take it up with the formulation of where those numbers came from.
So no, I don't. If we're making a logical argument, I can disprove any one part of it or the links between any of the premises that reach the conclusion. Right?
Okay, well then do that.
I don't have to specifically pick the bit you're talking about.
Sure you do.
I can easily find. No, I don't, because an argument is built of multiple parts and it rests upon every one of those parts. If any one of those parts is broken, the whole argument's broken.
Yeah, exactly. You're right, 100%. But both the P and the Q are built on the curve calculation.
Right, and if that curve calculation is wrong, what happens to the argument? If the curve calculation is wrong, what happens to the argument?
There you go. That's what I've been saying. Thank you. We're in agreement now.
No, it's a question. If the curve calculator is wrong, what happens to the whole argument?
It goes to shit.
Thank you. That's all I'm saying.
Yeah, that's what I'm saying. The curve calculation
is wrong.
Well, if the curve calculations are wrong, which is the curve this whole argument is based on the curve calculations. So if you can say that the curve calculations are incorrect, then the whole thing goes to shit. That's what I've been saying the entire time.
Yeah.
Yeah, they are wrong.
Well,
so then it's not a logically
all of your curve calculators are knackered. Then,
it's not.
Right? Go and have a word with them.
Yeah, That's what I'm saying is if you're going to take apart the P's and the Q's of the math on this, then take it up with the curve calculator, not
Yeah,
the
it assumes
formulation of the
the
actual
curve.
argument.
The curve calculator assumes a perfect sphere with 0 topography and 0 waves, 0 tides. So it's fucked.
Okay, well, take it up with the curve calculation guy.
Yeah, sure.
Right,
That's my point.
The syllogism is valid in its form, but what is lacking is the verification of the premises.
That's what it's based on, is the curve calculations. So don't get it twisted. I am not defending the QE BS Black Swan. That's my initials for it. All I'm defending is the logical formulation of it is correct according to the curve calculations. Now, if you have a problem with that, then you have to figure out how the curve calculations are incorrect. That's
so
all I'm saying.
So it's still
It's
wrong,
easy to figure out.
I would say, even if the curve calculator were correct.
Or in my opinion,
Please let me finish. It would still be wrong because of the thing I said before, which is disproving a given radius and disprove that there is a radius. Right? It's like saying there's not a dog in my backyard, therefore dogs don't exist. When I say it that way, you go, oh, of course, that's ridiculous, Harry. You wouldn't say it like that. But to say I disproved one radius, therefore I proved that there isn't a radius, is exactly the same logical formulation, and it's bunk.
well, you're going a little bit beyond the first part of that by going to the not Q part. But what I agree that there are flaws in it. I mean, to me, if I was a glober, I would say the first statement of the P part is if the Earth is a sphere with a radius, blah, 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 of X miles, I would say if I was a glober, I would say, well, the Earth isn't a sphere, it's a geoid. It's a geoid.
Yeah,
So therefore the rest
sphere.
of it's fucked.
Literally every
That's what
part of
I
it is
would
broken.
do personally. Or you can go for like, oh, well, it's not 3959, it's 3958.
Yeah,
Or
or
whatever you
39
want to do.
one way
Because it
round, but it doesn't
negates
actually have a
all of the
radius
rest
of
of it.
geoid.